Hello everyone, welcome back to my YouTube channel. Myself Nihar, studying in Sri Venkateshwara College of Engineering, Bengaluru in the Department of Computer Science and Cybersecurity. Today I am going to explain you all about confidence limits for unknown means. Introduction to confidence limits for unknown means. Confidence limits are statistical tool used to estimate the range within which the true population mean lies. They provide a measure of uncertainty and allow us to make inferences about the population based on a sample. Confidence limits are often used in hypothesis testing and decision-making process. Understanding the confidence levels. Confidence levels determines the percentage of confidence that an interval contains the true population mean. Commonly used confidence levels are 90%, 95%, and 99%. Higher confidence level results in wider confidence intervals, reflecting in greater uncertainty. Calculation of confidence limits. As you can see on the right hand side, how to calculate the standard deviation. There is a formula where n represents the number of data points, x suffix I represents each of the values of the data, and x bar is equals to the mean of x suffix I. Confidence limits are calculated using the sample mean, standard deviation, sample size, and the desired confidence level. The formula for confidence limits depends on whether the population standard deviation is known or unknown. When the population standard deviation is unknown, we use the t-distribution instead of the standard normal distribution. Confidence limits with non-standard deviation. When the population standard deviation is known, we use the z-score to calculate the confidence limits. The formula for confidence limits with a known standard deviation is sample mean plus or minus of z of standard deviation divided by square root of sample size, where SD represents the population standard deviation, sigma means the sum of n is equals to the population size, x suffix I each value from the population, x bar is equals to the population mean. Confidence limits with unknown standard deviation. When the population standard deviation is unknown, we use the t-distribution to calculate the confidence limit. The formula for confidence limit with an unknown standard deviation is sample mean plus or minus t of sample standard deviation divided by the square root of sample size, where standard deviation is equals to root of sigma x of I minus x bar whole square divided by n. SD population of standard deviation, sigma means sum, n means population size, xi means each value from the population, x bar represents the population mean as same as the previous one. Factors affecting the confidence limits. The sample size has a direct impact on the width of the confidence interval. Larger sample sizes result in narrower confidence intervals, indicating greater precision. The level of confidence also affects the width of interval with higher confidence levels, leading to wider intervals. Example 2 showed that 95% confidence level results in a critical value 1.96. This is the most critical value that is common, and it is listed with two other common values in the table that is shown below. Interpreting the confidence limits. Confidence limits provides a range of values within which the true population mean is estimated to lie. If a confidence interval includes a specific value, we can say with a certain level of confidence that the true population mean includes that a value. If a confidence interval does not include a specific value, we can say with a certain level of confidence that the true population mean does not include that specific value. Here is an example application: confidence limits in opinion polls. Confidence limits are commonly used in opinion polls to estimate the true proportion of a population who hold a certain opinion. For example, a poll might report that 60% of voters support a particular candidate with 95% confidence interval of plus or minus 3%. This means that the true proportion of supporters lies between 57 and 63% with 95% level of confidence. Here is another example of the common misconceptions about the confidence limits as shown in the previous slide. It is the same. Assumptions and limitations of confidence limits. Confidence limits assume that a sample is representative of the larger population. They also assume that a sample is randomly selected and that the data follow a normal distribution. Confidence limits may not be accurate if these assumptions are violated. Importance of confidence limits in decision making. Confidence limits plays a crucial role in decision making process, especially when dealing with unknown population meals. They help decision makers assess the reliability of estimates and make informed choices. Confidence limits provide a framework for understanding the level of uncertainty associated with a particular estimate. Conclusion: confidence limits for unknown means are a valuable statistical tool for estimating the true population mean. They provide a measure of uncertainty and help decision makers make informed choices. Understanding how to calculate and interpret confidence limits is essential for conducting reliable statistical analysis. So this was all about the topic confidence limits for unknown means. ವಿಡಿಯೋ ನಿಮಗೆ ಇಷ್ಟ ಆಗಿದ್ರೆ ಲೈಕ್ ಮಾಡಿ, ಶೇರ್ ಮಾಡಿ ಹಾಗೂ ಸಬ್ಸ್ಕ್ರೈಬ್ ಮಾಡಿ. ಥ್ಯಾಂಕ್ ಯು.